So, good morning to everyone. I am Dr. Manathan, Head of the Department Chemistry. I welcome all the bright young minds of our nation for this webinar on the topic Chemistry is Everyday Science. I also welcome our speakers, Dr. Nimay Mishra and Dr. Parthasarathi Maram, and my other colleagues, Dr. Magesh Kumar Rawa, Dr. Sabyasachi Chakrabarti, and other department faculty members, staffs, and other participants of this webinar. So when we talk about science, we discuss chemistry, physics, mathematics, and biology. Each science has its own significance. For many students, chemistry appears to be a real mystery. But in fact, it is really a magic. Yes, we can see many magic in our life. For example, when our parents buy a toy or mobile for us, we become happy. But when they caution us, we become sad. Why we become like that suddenly? What happens inside our brain? It's all chemical reactions. So chemistry is all about the reactions and its properties. In fact, by knowing the basic concept of chemistry, one can design and prepare a molecule or a compound. By knowing the properties of the molecules, we can use them for various applications such as drug, even prepare a drug for COVID-19 molecule. If it is not useful for drug, we can make materials such as plastics. We can use those materials for various applications such as mobile phones and in computers. So like that, there are numerous interesting facts lies inside the chemistry. So today, our speakers, Dr. Nimay Mishra and Dr. Parthasarathi Maram, they are going to discuss about many interesting facts about the chemistry in day-to-day life. And they will also tell us what made them to do research in chemistry, how easy the research in our university, especially at SRM AP. So at the end of this meeting, I'm sure that you will have your answers. So even at the end of the presentation, you can ask your questions just by raising the hands in the webinar, or you can also put your questions in the chat box. So with this, I invite Dr. Nimay Mishra, a faculty member in the Department of Chemistry, SRM AP, who has completed his PhD program in NUS Singapore and his postdoctoral degree in US and Italy. Currently, he is pursuing research. He means his research group pursuing research on the topic synthesis and optoelectronic applications of semiconductor. So today, he will also discuss about the semiconductors and its applications in LEDs, TVs. And thus, I welcome Dr. Nimay Mishra for his presentation. I welcome on behalf of all. Thank you.
Thank you, Dr. Manathan. Manathan, I'm audible?
Yes, you are audible, Nimay.
Okay. So I'd like to thank Dr. Manathan for his kind introduction. And as he said, we welcome all the high school students present here for this interactive webinar, which is meant to know some of the cutting edge research that's going on in our chemistry department. And if you remember, the theme of this today's webinar is chemistry is everyday science. Dr. Manathan rightly pointed out few aspects how chemistry is involved in our daily lives. So what motivates us to make or to host this kind of webinar? As all of you are aware that we are going through a very difficult time in this pandemic, a very tiny virus showing us how difficult the life could be. And then if you think about that, what could be the solutions, as all of us are looking for a solution, and basically all of us are looking and hoping and praying that a chemistry or a chemistry laboratory work can produce a drug or vaccine that can help us to cure from this deadly virus. So that's actually motivate us in current times, that chemistry become more relevant than before. Chemistry actually always relevant, but from the modern young age students, this is the right time they can think about that how chemistry be useful for not only for drug discoveries that now the scientists are doing now, but there are many other areas. So as in today's webinar, we're going to highlight few of those interesting topics that chemistry has been contributing in our daily life. Thus, webinars will be successful in future if we able to motivate at least one student to pursue their higher studies in sciences, in particular chemistry. That day, this webinar becomes successful. In future, maybe one of you write us an email or contact us, sir, is because of that webinar your Department of Chemistry did in 2020. That gives me a opportunity to think about basic sciences, in particular chemistry. So I chose chemistry as my future studies, and today I'm doing so and so. So that day will be very happy about it. So now let's come to this today's topic. My today's title, that chemistry of semiconductor nanocrystals. I'm going to discuss how the chemistry can be helpful to synthesize some of these nanocrystals, semiconductor nanocrystals. Many of you may not understand what is I mean by nanoparticles, but I believe all of you are aware what I mean by semiconductor. So I'll discuss briefly about what is semiconductor and what are nanoparticles, and then I'll discuss how the simple laboratory chemistry can be useful to make your display devices like televisions, all LED lights, mobile, other gadgets. So this is the main important points here. Why semiconductor nanocrystal? For time being, you can excuse me. In a moment, I'll explain what are semiconductor, what are nanocrystals. Okay. So why this semiconductor? Let us understand in this slide why semiconductor nanocrystals are using for this light emitting. What is light emitting? This is LED. I think all of you are aware of what is the LED. It's a light emitting diodes. It is very easily available if you go to any shop, any electrical shop. So even though you don't know what material are used to made of these LEDs, but I believe all of you are aware of the name of LEDs. So is this solution process in chemistry laboratory can use to make this beautiful, interesting semiconductor nanoparticle that can use in display industries for various reasons. I listed few of them. In the beginning, you may not be able to understand what I'm talking now, but in a moment, as I said, I'll again come back to these slides and I'll tell you, I hope I'll be able to make you convince you at the end. So these are the reasons and how chemistry has been involved in these display industries. So why semiconductor nanocrystal, as I said, because they can make your TV very high efficiency, which is everyone is looking for. Everyone is looking for very high quality televisions, high quality in a sense of picture quality, high quality in a sense that can consume less energy. Okay, and this would have a white color gamut. This may be a technical term, many of you do not understand. So this means the purity of the color, it should be very natural. That's everyone's looking for. Whenever you're buying a new phone or new TV, you are looking for these features. Low turn on voltage, it is related to the energy savings. That means, you know, nowadays you can see your ACs, your freeze, they're coming 4-star, 3-star, all those things. That means how good is this instrument in terms of using energy? And of course, low manufacturing cost. Everyone wants to buy a very cheap devices with a very high quality. So these are the things that semiconductor nanocrystal industry, I'm saying, so this is the chemistry laboratory approach that can help to make your devices much cheaper and with high improved qualities. So I introduced two terms in this slide. What is semiconductor and nanocrystal? So let us understand why semiconductor in electronic devices. This is very routine slide, and all of you in the high schools, you have gone through this. And I believe all of you understand in your high school studies that the material which are available in terms of our periodic table and in terms of whatever available in our nature, that can be classified in broadly in three different areas. What is metal? Another is semiconductor and insulator. So metal, where the valence band and conduction band, they overlap each other. That means they are highly conductor of electricity as well as heat, because they have abundant of electrons that can easily, you can see from these conductor valence and conduction band. On the other hand, the other extreme, which is insulator, because there is a wide band gap between valence band and conduction band. So what is the example? Like a wood, it cannot conduct electricity. It has a huge band gap. But there is something interesting material that can be found in the periodic table, which is semiconductor. And they also have a band gap, but not like a wider like insulator. So this is our point of interest. Now, naturally, question comes, why semiconductor? Why not metal? Why not insulator? The reason behind, I listed a few. You can go through many YouTube videos, okay? And then you can find out they're all detailed, but here, due to short of time, I'm giving the very key points why people use semiconductor in the electronic devices, because we use a material that can be controlled easily the conductivity. If you see the metal, you cannot control the electricity because it has an abundance of electrons, and valence band and conductance band, they are overlap each other. On the other hand, insulator you cannot use because the band gap is very, very wide. But semiconductor being in the middle, if you use external forces, some as like a voltage, some temperature, you can easily tune the electrons from the valence band to the conduction band, and you can make the electron to run, and that's the electricity. So it is not easy to control conductivity in the conductors. But the transistor, which is the main part of every electronic devices, which is working as a switch, that means on and off. What is on? You excite or you give some agitation to the valence bond electrons, and they go to the conduction band, and that start of running electricity. So you need something, this kind of material, which has a band gap, but same time can easily controllable with some external force. It could be external voltage, it could be temperature. So that's why semiconductor is the only choice that can use to make different kind of transistor. Okay, so I hope you guys now able to understand why you need semiconductor. Then I have pointed out one more term, semiconductor nanocrystals. So let me introduce what is nano here. I believe all of you are aware of what is nano. If I ask you the question, what is nano? Maybe many of you give answer. Nano means is very small. Okay, many of you maybe give you answer. Nano means Tata Nano car. Then you can recollect, you connect to the common sense. What do you mean by Tata Nano car? The logic behind why name Tata name it Nano car, because it's become small compared to the other varieties of the cars available. So nano means it's very tiny. Okay, so let us see, we have understood what is semiconductor, why it is important for the electronic devices. So let us see what is the nanoscale, what is the nanocrystal. Then I'll connect to the nanoscale to the nanoscale. Then eventually I'll connect the semiconductor nanocrystal. It will be make more clear picture to you guys. So let us understand the macroscopic scale. What is macroscopic? In a naked eyes, whatever we can see, that's called macroscopic scale. Our vision range could be 1 kilometer. Okay, we can see what are the people in front of us. That's called macroscopic scale. A car, a roads, trees, whatever you can see in front, that's called macroscopic scale. Then one more scale is called galaxy scale. What is the galaxy scale? If you see in the sky in the night, okay, you see the stars and moon. So these are called galaxy scale. This is beyond our reach. Okay. And then on the other extreme, it's called microscopic scale. It's not the extreme, sorry. This is another scale called microscopic. So see, we're narrowing down. We're coming from macroscopic to microscopic. What is microscopic scale? Let's say this is an ant. We can easily see an ant with our naked eyes. But are you able to see the eyes of an ant? No, may not. Until unless you catch the ants, very put it close to your eyes, you're not able to see it, even though it is not very clear. So that time we took a help from a microscope. Okay, and this is called microscopic skill. Many of you have done the C-section experiment of plants in your high school biology. You put the C-section of the plants underneath of an optical microscope to zoom it. So you need some sort of that kind of machine to enlarge the view. So that is called microscopic skill. We cannot see very clearly with the naked eyes. Now see another extreme. That's called atomic scale or subatomic scale. What are the subatomic particles? Everybody know: electron, neutron, protons. Okay, these are very, very tiny fundamental particles. And then made of those particles, fundamental particles, they made atoms. So what is the size of atoms? If you recollect from your 10+2 or even 10th class physical chemistry or physics, the size is femtometer, 10 to the minus 15 meter. So those are the size of atoms, very tiny, 10 to the power minus 15. Now, in between these two extremes, what are those two extremes? The macroscopic scale and the atomic scale. There are middle ground that's called the nanoscale. So nanoscale, the naturally questions come, what is the dimension? Here the dimension is nanometer. What is nanometer? 1 nanometer equal to, all of you know, it is 10 to the power minus 9 meter. So basically when you put 100 to 1000 atoms together, you make a cluster, then you can call is a nanoparticle. I think I able to make you guys understand. This is some of the example of nanoparticle. You may not be able to see what are these, but I can give you a very known example. All of you have studied DNA, RNA in your class, biology class. Those are nothing else. Those are nanoparticles. Because why they are calling them nanoparticles? Or I can say nanobiomolecules, because their size are in range of nanoscale. Okay, so they are size of 2 to 3 nanometer. So see, this is the two extremes. So hope I am able to make you guys clear. Though this is in between the macroscopic scale or microscopic scale and the atomic scale. The nanoscale regime, which is nothing else, made of 100,000 to 100 to 1000 atoms, that's called nanoparticles. Now again, it can seed one more question to you guys, the why these nanoscales are important. This is important because there are many properties changes in this scale. I'm not going to details all those things in this today's webinar. Well, there is another opportunity we can discuss. There are many YouTube videos you guys can go through that why nanoscale is important. Okay, just I briefly connect you any of the properties of any material. Why I'm talking about material? What about applications? As Dr. Mannathan said, like a plastic. I also introduced in the beginning the COVID-19 drug people have been working. This is all materials, either organic and inorganic materials. Whatever example you see in this life, starting from drug, plastics, electronic gadgets, all are used or made of materials. Okay, so when you make this material in the nanoscale, what is the nanoscale? 1 to 100 nanometer. What is 100 to 100? 1 to 100 nanometer means it is composed of 100 to 1000 atoms together. Okay, so this is something different, the bulk material. What is bulk material? Many of us use gold ornaments. If you see gold on your earrings, okay, or you can see on your finger rings. So those gold, if you make it tiny nanoscale gold material, that you can say a gold nanomaterial. Okay, so what actually happened? As I said, all this material has fundamental properties. That's why you choose based on your application, need of your application. But when you make this material in the nanoscale, their properties, physical and chemical properties changes, and that's why the nanoscales is being the important point or important area of research. Okay, so I hope it is clear why it's nano. What is the nano? Now, let me go back to my original slide. You can see my title, the semiconductor nanocrystal. Then why is the semiconductor nanocrystals? I've given enough motivation to you guys. The semiconductor in the nanoscale has many new interesting properties. I'm not going to discuss all those interesting properties because this topic is today's not discussion only on the nanoparticles. I'm going to discuss you how the laboratory chemistry can help you for the electronic industry. how a young student like you can pursue your higher studies in chemistry and be part of this fascinating science. That not only a basic science is the interdisciplinary, you can work with the engineers, electrical engineers, and you can make this beautiful, contribute to make these beautiful devices with very high quality. So semiconductor in nanoscale has many interesting properties, which can further improve the electronic devices. So that's the point. That's why I gave enough information, why semiconductor, and then why in the nanoscale. Okay. Now let's just come to the directly to the our today's topic, that how chemistry can help to make the semiconductor nanocrystals. Why chemistry being so important? I'm going to discuss a very simple point of view, making semiconductor nanoparticle using colloidal chemistry. All of you know about colloidal chemistry. In a moment, I'll show you what is actually colloidal chemistry to connect you guys for your 10+2 studies. But let us see. Is the chemistry is nothing else. It's like a cooking chemistry. All of your moms, or even all of you, have done some of the cooking in your home. I believe all of your high school students, and maybe some of you in a very late night when your mom was sleeping and you guys feel hungry and you want to cook something and you find out there is a Maggie, there's a cup noodles, and then you find out you just put a hot water and then can make you eatable. So you can sustain. So this is simple a cooking chemistry that all of us done. Maybe a very fine morning, you want to make some coffee for yourself. You mix coffee with milk and sugar, depends on your choice, is the simple cooking chemistry. Okay, so chemistry is nothing else. Making new material through chemistry is nothing else. It's just like a cooking. Like this gentleman is cooking something. Okay, now can we make this simple cooking in the laboratory? How can I do it? In the lab, in your kitchen, you need this kind of apparatus to cook your food. But in the chemistry laboratory, the same cooking we're going to do it, but some modified ways. So this is the modified things, you can modified apparatus that we need to cook. In a kitchen, we use induction oven, we use gas, but here we can see the hot plate oven. Okay. It's not oven, I can say it's a hot plate. You can use oven also, people use oven. And instead of this kind of crockeries, use a glass crockeries here. And then just take an example of cooking a rice. How do you cook a rice if you ask a question? This is very simple, isn't it, guys? Very, very simple. Everybody has a common sense can give this answer. You put the rice in a water and then boil the water for a certain time. So what is the important point here? You need to boil the water for a certain amount of time, or a fixed time. And which determine the fixed amount of time? It is the what quality of rice you are using. Based on the rice, the time can changes. So, and then you are boiling. What is the temperature? Since it's the water, it's 100 degrees. So see, there's two things. You are heating the stuff and you are heating for some fixed amount of time. Your rice is ready. The chemistry in the laboratory, now in the kitchen, you are making rice. In the laboratory, you are making a new molecules. My colleague, Dr. Mannathan, he do different kind of organic synthesis, which is again, that people have been working in the COVID-19 laboratories to find out the drug is nothing else than the organic chemistry. Okay, make it more simple. What is the common medicine for having a fever? It is a paracetamol. If you want to synthesize this paracetamol, you want to go through this kind of setup. And you need some solvent. In terms of cooking rice, it is the water is the solvent. Or in this case, it is some other solvent. Then you need a perfect temperature. In cooking rice, you need a temperature of 100 degrees. But here could be different. So these are the similarities, but in some modified ways and controlled manner. So chemistry of synthesis of chemistry of new materials is nothing else is a cooking chemistry. You often say, you guys are foodie lovers, you go to the restaurants, enjoy the biryanis, and then you tell and complain, oh guys, the biryanis my mom cooked is the best biryani I had. Then you go and ask your mom, what is this? What is your habit in the biryanis? Your mom says it is over the years experience. Your mom knows the proper blending of masalas to make your biryani the best. The same thing way, it is also proper. What is the masala? Is nothing else chemicals. Here also is a proper blending of different kind of chemicals in terms of your choice to produce some new materials. So I hope you are able to understand and connect a cooking chemistry which is relevant to make new molecules. Okay. Now come to the colloidal solution. All of you are gone through this. Okay, why we need a colloidal chemistry is very simple. Colloidal solution are very simple. In the third extent left is a 2D solution. When the particle size are very tiny, less than 1 nanometer, 10 to the minus 7 centimeter, which is less than a 1 nanometer. And there are further extent with the suspension. When the bigger particle in the water, like a mud, okay, and those are settled down after some time because the particle size are micron, very big. Those are called suspension. But in between, this is called colloidal solution, something, a real example that you can connect, which is called milk. Okay, that is a neither solution nor the suspension. So these are something chemistry we have used to produce semiconductor nanocrystal in the chemistry laboratory. You can assume from the time being those white dots are nothing else than nanoparticle, and this blue is the medium where the nanoparticle is suspended. Okay, so like the color, like this is the way the fundamental chemistry, which is in this case colloidal chemistry, has been used to produce some of the beautiful nanoparticles. Okay, so let's see. So we have understood semiconductor, we understood why nanoscale is important, then we understood how the chemistry, cooking chemistry can help you to produce those materials in the laboratory. So let us see actually what are the semiconductor nanocrystals. These are very tiny particle, as I said, in the nanoscale material, 1 to 100 nanometer. And they also name it quantum dot. Why they call it quantum dot, I'm not going to give you more details here. Again, you guys can go to the YouTube. This is something, another acronym or name based on some scientific features. Okay, so this is also called quantum dot, and that's the synthesis model I have discussed. Is called cooking chemistry, but in a laboratory. Okay, and then you need to put some of the chemicals, like chemicals in this case, like you are cooking your rice, you are putting rice, you are putting chemicals. What of the material you want to synthesize, you have to put that chemicals. We need to check the temperature, we need the thermometer, we need to boil it, so we need a solvent. Okay, at the outcome, these are the material. This is a schematic diagram, but what could be the real picture? So this is a real picture. Okay, this is a very tiny, see the scale very 20 nanometer, very tiny nanoparticles. Okay, made of this cooking simple chemistry that all of you can make it. Okay, and why this important? Because of this image. Okay, you can see all those tiny particles, they can give you very bright emission colors. It's starting from blue to red, all our VGO. So that's why the semiconductor nanocrystals, because of some of the fundamental physics property, it is called quantum confinement property. I'm not going to discuss here details. I'm just want to connect you that how colloidal chemistry can make use of cooking chemistry to synthesize these beautiful tiny nanoparticles. Those have wonderful emissive properties. Now let us see why this is semiconductor nanocrystal is so important. Because this semiconductor nanocrystal, they can give pure color. Why I'm discussing about this emission or giving color? Because see about today's topic, I'm discussing. The topic is how semiconductor nanocrystal, chemistry of semiconductor nanocrystals can be useful for the display industries like LED TVs. What is the display? Display means giving light. What kind of light? All VGO. So these are the image. You can see the nanoparticle, tiny semiconductor nanoparticle. That's the point. Tiny semiconductor nanoparticle, they can give light, whatever color you can think of. Okay, so this nanocrystal can be added as the backlight on your LED TV, and that can make a very beautiful, very high quality display. I'll come in a moment, and that can give you very good picture quality. Okay. Okay, now again, as we know, all of us are working in the SRM University. What we can do here? So these are some nanoparticles. This image is not taken here; it is taken in the United States. But these nanoparticle also we can synthesize here in SRM-AP. We have already made the laboratories, research laboratories. We are already pursuing, the 5 faculty members. We are pursuing cutting edge research, starting from the material chemistry, theoretical chemistry, organic chemistry. Okay. And here we can make these materials. The high resolution TM here that has done in the United States, but the material synthesis has been done here. And this is the real photograph of this material under UV light. You can see different color is coming out of the material. Okay, so if you guys are nearby from the Guntur Vijayawada region here or somewhere close to this Amravati, you can always visit it in near future when the things get settled, when the pandemic goes over. You can write us to email. You can find our email from the website. You can visit our laboratory. We can happy to show you the how chemistry laboratory, research laboratory, with the help of our PhD student, we are producing this kind of interesting material, and that can solve many of the key problems. Okay, so we have understood semiconductor nanocrystal. We understood why it is important, the nanoscale semiconductor, how it's synthesized, and then let us connect to the today's topic. How can you make the LED devices? Everybody knows LEDs. Okay, I'm putting here very simple schematic, but rather actual process being very complicated. But you can see the quantum dot, as you know, the semiconductor nanocrystal also named as a quantum dot that I mentioned in the previous slide. So later on I'll put as a quantum dot, or acronym is a QD. So these are the quantum dot. Why quantum dot? LED, what is mean? Light emitting diode. That means you need a device that can emit light. So that's we have been doing here. And you can see from the previous slide, these nanoparticles made of semiconductor that can give you pure color. So that's why we are putting color based on your choices. We can make LEDs, can be green LEDs, red LEDs, and blue LEDs. So these are the some beautiful LEDs that have been using nowadays, decoration purpose. Okay, and everywhere street light has been used, a white LED, the street lights. Okay, and then decorations and the TVs, gadgets. So these are the fundamental behind of making LEDs. So now how this quantum dot, which is semiconductor nanocrystals, how they work in the display industry. Okay, this is a model taken from the Samsung. Samsung is the well-known company who made this all gadgets and televisions. So they made first this quantum dot or semiconductor nanocrystal based television. Many of you may have heard of QD LED TVs. Okay, so this is a simple model taken from the Samsung website. All of you can go through. Okay, and this is the font layer having all those tiny nanoparticle printed. Okay, and then there is a blue backlight, and there are multiple, you know, what is the important features the TV has. It is the same as the LCD TV. Instead of we are putting here quantum dot layer. So quantum dot technology, that's why it's called quantum dot technology. Quantum dot technology doesn't mean it's a quantum mechanics. Okay, the particle as a name is a quantum dot. That's why I call quantum. There's a real chemistry. Okay, so quantum dot, through our chemists, they printed on top of your televisions, and their technology is most successful employed in new generation LED backlight LCDs, TVs. These displays are utilizing similar principle as the LCD TVs. Okay, and but there are advantage. I'm going to say you what are the advantage, okay, of this TV. So see the one of the real image example here. A normal LED TV and is quantum dot or semiconductor nanocrystals based LED TV, which is synthesized in a chemistry laboratory, fabricated by a chemist and collaborated with the engineer. They made it in this TV in the Samsung R&D sector, R&D. Okay, you can see the color of this frog. The natural color is something more deep red and more deep green, which is missing in this normal LED TV. But in the QD LED TV, the color is more pure. That's the important. Whenever you're going to buy a new gadget or TV, you're looking for quality of the picture. So that's this quantum dot LED TV can give you. And how do you make this quantum dot? It is a simple cooking chemistry. That's your role is. Okay, you are passionate about science, passionate about chemistry, you can also make this kind of tiny nanoparticle for various applications. Okay, so then here I'm almost at the end. These are the advantage of this quantum dot LED TV. Okay, that's the very beginning slide. You remember whenever I told you that why, when you're going to buy a new gadget, what could be your criteria? This is the criteria. Why this quantum dot technology offers this advantage? The advantage, very good brightness of the color. They give you very pure color, and their energy consumption is very low. You need very small amount of light, so your power bill is low, and they have very improved color accuracy. Okay, because you can see the VIBGYOR. What is the green? What is the next color of the green? It is the yellow. So sometimes if you put a green, it may be yellow's green, but this technology, green can be pure green. Red can be pure red. So that's the interesting fact. And what is the basics behind, as I explained, it is semiconductor nanocrystal, and that can be synthesized only by means of cooking, simple cooking chemistry in the chemistry laboratory. Okay, so that's why this is are very important, and this is the next boom in the display industry. All of you are going to have it. Now the price is bit higher, but future is this kind of technology already in market, and hope many of you have seen it in the television stores. So I hope I give you enough information. So what could be the take home message for this talk? We have been thankful to doctors, nurses, engineers in this pandemic, in this crisis. Okay, so they have been contributing something. Why I'm not able to do it? But we're not able to see the people behind running the show. There are thousands of chemists. They have been working day and night in this COVID laboratory. Either you do a COVID testing, it is a simple chemical reaction going on. The PCR chain reaction is going on. The DNA and RNA using a DNA and RNA. It is a simple chemistry reaction that can tell you a person is COVID positive or not. People have been talking about different trials of different drugs. And this is a chemist all across the world, including in India, people are working to develop this kind of molecules. Okay, so what chemist can do? It can find solution of many modern day challenges. Who can do is a young student like you guys. There are many challenges for hunger, poverty, and that pollution, energy, diseases. The today's topic, my topics related to the energy, LED TVs, okay, saving more energy. So these are the problem, top to bottom, morning to evening, whatever you can see, many problems, all are related to chemistry. We can solve it. Okay, so with this, I'm going to end here. I'd like to thank all the students and thank you for your patience. So I'm now over to Dr. Manathan. Manathan, how we do? We'll take some questions, one or two, or we'll.
Yes, we will wait for the audience
Okay.
to take the question. So before that, any question from audience? Participants? Okay, so now I see one question from Chand. Yeah, Chandragiri Rishita. So she
Yes.
put a question, sir, what happens when we improve the HD quality? Is that good for eyes?
Okay. Honestly, Harshita, right?
Yeah,
Rishita, sir.
Okay. Okay, Rishita. Oh, Rishita. Okay, Rishita. Yes.
Yes, yes,
Yeah.
sir.
Rishita, I do not have answer right now about what the high HD quality will affect on your eyes. Definitely, if you any gadgets you see for a long time, it's not good for eyes for sure. Okay. Yeah. So I do not have aspects of how it's going to affect on your eyes. Okay, so what we have discussed today, how this chemistry can synthesize these materials and that can improve the quality, but how it is effect on the eyes, I never I didn't read it. Yeah, so I cannot answer right now, but I can look into it and you can write me an email, or maybe I can ask any of my colleagues. Partha, do you think you can answer this?
So whatever you see high definition, it usually helps you to get into the every detail of the picture. You know, basically it is helping you to understand the clear picture of it. And the color rendering, basically the colors which you see in the LCD LED background is completely different than when you see in the quantum LED or a OLED. I don't say it has any side effects because all the blinking quantum dots and everything, they were taken care while fabricating the device. And more than HD, in my opinion, people are coming into Ultra HD and 4K, where you will not have that sensitivity anyway to your eye. So it is an overall picture of the image which you look better, but usually there is no impact on your eye as per my understanding. It's usually helping you to understand the picture much better.
Okay. Yeah.
Thank you, sir.
Yes. Yeah.
Okay.
Thank you, Partha.
Hello, Dr. Mishra.
Yes.
So there is one more question from Pranjul.
Uh,
So his question is, what are the materials required for making quantum dots?
Okay, so this is even some of the means based on the what kind of material quantum dot are going to synthesize. I can give you a common example of quantum dots, which is cadmium selenide. Okay, if you synthesize cadmium selenide, this is the most well-known quantum dots. to date. So that, you know, two elements is there. If you think about from periodic table, cadmium is there, selenium is there. So you need cadmium, you need selenium. And you cannot take those things from elemental. You can find those cadmium as a cadmium salt, selenium also selenium compound or some salt. And then if you mix it, as I said, some modified cooking chemistry you have to do, then you can synthesize quantum dots. CDSC quantum dots. Yeah.
Okay.
Is there one more question from the audience?
Okay, I think this chat box is still open. So if you still have question, you can put it there. So after finishing our another next speaker, Dr. Padamaram's talk, we can also take those questions.
Sure, sure. That's better. Yeah.
So with this, I just thank Dr. Nimay Mishra for his wonderful presentation on semiconductor nanocrystals. So he explained semiconductor nanocrystals in a very simple way. I hope the school students now they can able to see or think about this nanocrystal research, and hope they are all motivated to pursue the higher education. And I also feel he also discussed the future quantum dots LED devices. The students might also update it with kind of new technology. I thank Nimay Mishra on behalf of all of our participants and speakers. I thank you so much, Nimay Mishra, for your wonderful presentation.
Thank you, Dr. Manathan.
So next, I would like to invite Dr. Parthasarathi Maram. He is a faculty member in our Department of Chemistry. So Dr. Parthasarathi Maram has completed.
Sir, one question please. Sir, one question please.
Hello?
Hello?
Sir, one question.
Okay. About what?
Sir, what is the reason for reducing drain doping in metal oxide semiconductor device design?
Can you repeat again your question? I didn't hear it properly.
Sir, what is the reason for reducing drain doping in metal oxides semiconductor?
Grain dropping.
Yes, sir.
What does that mean? Even I am not. Can you explain a bit? What do you mean by that?
Okay, Nitin Kumar.
Yes, sir.
Okay, we will take your question at the end. You can also put it in the chat box. So let us the other speaker starts. Let you complete his presentation. We are happy to take your question at the end.
Okay. Thank you, sir.
So Dr. Parthasarathi Maram, he completed his PhD in Indian Institutes of Technology, Madras, and he also had vast experience in undergoing postdoctorate program in the University of California, Davis, USA, and he came back to SRM University-AP, and now he is working on solid-state electrochemistry, thermodynamics, and ceramics for hostile environments. And today, he will discuss about the interesting fact in this area in day-to-day life. So his talk is focused on chemistry of ceramics and its application to aerospace industry. So I welcome Dr. Parthasarathi Maram for the presentation.
Thank you, Dr. Manathan. And thank you for all the participants who are attending this webinar. Basically, I'm going to talk about the chemistry of ceramics and its applications to aerospace industry. Before going to the topic, the main objective of this webinar, as Dr. Nimay Mishra said, to give a glimpse of fundamental science to the cutting edge applications to the students who are actually looking for program to study or looking for a university to go and pursue their studies. So what happens is if you listen to these kind of webinars, you will have understanding about what is technology and the chemistry, and maybe you look for sciences degrees and other things. As Dr. Nimay Mishra gave a wonderful presentation on how a fundamental chemistry can make into the technology something like a quantum devices, basically QLEDs. Actually, I have one of that, and I really enjoying that because of the scientific invention that is guided through the chemistry. So, in that line, this webinar is basically we focused for the 10+2 students and undergraduate students who are about to join in undergrad program or who are continuing in the undergrad program, so that they can get to know the whatever the day-to-day things are something they are using it, but they don't know what is really the science behind that act. So for example, if you look around where you are sitting right now, if you look around, you will see different types of materials. I would say you might have noticed the plastic, you might have noticed the wood, you might have noticed the wall. So all these materials are made with different elements, and because of those elements, they have very different properties. The wall which you are seeing is very rigid, and it has a very good strength. And the plastic you see is you can use it for sitting, and you can use it for writing, something like that. And the glass you are seeing is a transparent. So these materials, how the constituent elements within this material, how these materials are made, whether is there any chemistry behind these materials, or the discovery or making of these materials is guided through the chemistry, and which is you are using every day. You are using every day chair, you are using every day, you are sitting in the wall, you are sleeping in a bedroom, you are using a bed, and everything is composition of materials. So the chemistry or the science that deals with these materials, we call it as a material chemistry. If you talk in general, we call it as material science. So today I'm going to show you some of the ceramic products or objects which you come across every day, how these objects and their compositions leading to develop artifact or to develop objects in aerospace industry, how they showed the way to develop aircraft parts. Okay, so that is the target and objective of this small talk. This is going to be a very small talk. So the content of this webinar is basically I want to discuss about the history of ceramics and their classification, properties of ceramics, and what are all the advanced ceramics currently people are using it, and their applications. Remember, ceramics is only one type of material what we are seeing currently around you. There are many other types of materials. When you classify materials, there are 4 types. Let's say in general, there may be more than that, but significantly we can classify into 4. Metals, the one which you are using maybe for electronic conduction. Copper wires is made of copper metal. Polymers, without that you cannot have a day. Polymers is completely developed based on chemistry backbone. We would say carbon and hydrogen chains making a polymer. Polythene is a polymer. The plastic chair you are sitting is a polymer. The laptop you are seeing is a polymer. The phone you are seeing is a polymer, made up of polymer, composing polymer. And ceramics. So this is what today's topic of interest is, ceramics and composites. When you have a blending of the polymer, ceramics, metals together like a physical mixture, you can call it as a composite. So all these materials will have a different properties. Metals conduct electricity, whereas ceramics are insulators. And ceramics may be more unreactive or unresponsive. They are very stable, in my opinion. Chemical stable, thermal stable, because they are stable with the temperature also. And whereas metals, they have a medium to high melting points, but they have high density. But they have one peculiar property that not any other material doesn't have, is ductility. Something like a gold. If you want to shape the gold in any form you want, you can do it because it has a metallic nature. It's a metal. Basically, gold is a metal, so that's why it has a ductile property. So if you see the classification of materials in general, you have metals, polymers, ceramics, and composites. All these materials has elements inside. Those elements are coming from the periodic table. That periodic table is the basis of the many inventions and many discoveries what we have currently using. Okay, if you go to the history of ceramics, history of ceramics is very well known. Basically, ceramics is one of the most ancient industry going back thousands of years, roughly 24,000 BC. That time, humans realized that there is an abundant quantity of a clay or a sand, and they found when mixing with water, they can make desired objects. And once you fire that, you are making a ceramic statue or a ceramic tumbler or ceramic glass. So that is how the ancient people first noticed that, okay, we can make certain objects with sand or a clay and water mixing together and firing it. The firing will stabilize the shape and you can repeatedly use this. So that is how the ceramics came into the everyday life of a human. If you date back around 24,000 BC, the Venus small statue, the first one I showed here, was found in Czech Republic. This was the oldest ceramic people dated back. And in early 17,000 BC, people found in a cave of China, China, where the ceramic statues soldiers were found in a cave. These are first evidence in Asia that ceramic pottery exists. And in Japan, around 10,000 BC, they found certain artifacts. And the pottery wheel was first invented in 3,500 BC. Once they invented pottery wheel, they started replicating what are all people found artifacts and making into shapes. In fact, the one which I shown here with a candle is recreated after inventing the pottery wheel. So what I'm going to say here is the ceramics are there from ancient times. People are using it without knowing much about the compositions. Because they are useful that time, they were using it. But now, how these ceramics are modified, how these ceramics are consisting of what elements inside. Can we change the ceramic compositions? Can we change the usability of these ceramics? What is their peculiar characteristics? Then you can see how well we can use for the cutting edge applications for today's technology. If you see the ceramics evolution here, back to Mesopotamian and Indian ancient history, you can see the Venus statue was found in 25,000 BC, dated back. Of course, if you do see, the evolution is increasing. And early 500 BC, they first started glazing the ceramic things. So you have a smooth ceramic surfaces, statues or anything. So you can glaze with the tin or you can glaze with other materials, but the glazing was first time did in 575 BC. And then cutting edge ceramic products are right now you are using for the day to day. And now the ceramics are everywhere where you cannot avoid anymore. Okay. If you know that you are using something, I have a particular observation or a character. If I am using something, I want to know about it, how it is originated, what is the composition of it, can we recreate it, can we make it, what is the science behind it, how these people thought about making this kind of device. So if you see, this technology or this ceramics industry is there from ancient times, but what is its guiding? What are all the elements? Can we recreate it? Okay, can we understand more about the ceramics? This is what the science we are going to discuss today. So if you see, as I said, there are ancient ceramics, we call them as a traditional ceramics, and there are advanced ceramics for the current dated. Okay, basically the traditional ceramics, what you see is a whitewares or China, clay products, bricks and tiles, abrasives and cements. Whereas the advanced ceramics, once these engineered ceramics, we call it as magnetic ceramics, optical ceramics, or nuclear ceramics, or bioceramics. tooth implantation, okay, or biomaterials which they put inside your body when you break your bone or something, biomineralization we call it as, and then automotive ceramics. So if you see one peculiar characteristic which I already noticed while giving first few slides, that ceramics are clay products. Ceramics are made by mixing with water, and ceramics are fired at high temperature. Even though you are fired at high temperature, they are very stable, and they are, even when you fire, they get more strength, looks like. Okay, you fire them, they are getting more strength. If you see the modern ceramics where people are using, it's a fitting of a ceramic tools to the aircraft engine. Okay, it went to that level where ceramics are used in aircraft engines now. Okay, so if you go and see example for each one, okay, so you have a ceramic spark plugs here, and a ceramic gear wheel, ceramic cutting tools, ceramic floor tiles, ceramic what is that, china, ceramic white wires, and ceramic glass. So everything could be made using ceramics. That's why they find applications in as glasses, clay products, refractories, abrasives, and cements. So now what I'm going to say is, okay, you have an idea about what is a ceramic now. So, but we need to know what is the chemical composition of ceramics. What are all the most popular ceramics? What are all their characteristics? So if you see how these ceramic objects are made in the ancient days, okay, people take a clay powder, which is well grinded, very soft and small grain powder, mix with the water and frame into the shape, which shape you want, and fire into the kiln. Kiln or a oven we call it as. When you fire in the oven, this is what happens. When you take a loose powder, in the bottom picture I can show you, and mix with the water and you dry it, and then once we fire it, it will settle. Okay, it will fill the gaps and make it more resistant. So this is how the traditionally ceramics are made. And how do you make a fine powder? Of course, you have a crushers, ball mills and other materials or machines to crush the stones and powders to make it a fine, granules of the clay powder, so that you can use for making the ceramic objects. This is a traditional. So the best well-known ceramics are the ceramics that are part of the every ceramic composition is, we are discussing here now. First one is alumina. I think so most of you know what is alumina. Alumina is the most widely used oxide ceramic. If you mix with oxides like silica, magnesium, or aluminum silicates, we call it as another ceramic called mullite. Okay, these two, alumina and mullite, find very interesting applications. Okay, how many of you know that alumina, you are using it every day, but you don't know that is a ceramic and that is an oxide that has very different characteristics. That is the reason why you are using it. Let's say most of you knows that what is a spark plug. Spark plug is a combination of metal and ceramic part. Okay, the ceramic spark plugs usually runs longer life than a metallic and combination of any other material. So ceramic spark plugs are very popular, and the ceramics they made here is a mullite and alumina. Okay, why the alumina uses for the ceramic spark? Because it is high hard, it has very good strength, it's a good electrical and thermal insulator. Okay, it doesn't transmit heat to one place to the other place. It's a thermal insulator. So if you remember, when you are using a thermal insulator, which means your walls, whatever made with the brick and the cement, is in fact they are thermal insulators. The moment you see the outside temperature, and when you go into the room and close the doors and see inside the temperature, it is very different. Why? Because the temperature which is outside is not transmitting inside. The wall is acting as a thermal insulator. So the wall is made up of ceramic compositions like cement, brick, and stones. So all these are thermal insulators, and that's why they are using as spark plug connectors. Okay, so as a refractory material for high temperature, spark plug insulators and thermal barrier coatings, which I will explain later. So these are the very interesting applications are found for alumina. And if you go for another ceramic material, which is zirconia, zirconia has a very characteristic characteristics. It's a you all know the C-jets, a cubic stabilized zirconia. We call it as a C-jets. They are used as a jewel stones in a jewelry. Why? Because they are used in the jewel stones because they don't corrode, they don't lose their luster. Okay, they don't wear off. Even if you drop the stones, they have very high thermal shock absorbers, so they don't break. The crystals doesn't break easily. They absorb all the shock you are giving it. So that is why zirconia is used as a high-end ceramics, and the cubic stabilized zirconia used as jewel stones, C-jets. So how many of you know that C-jets are made from the ceramics? That is zirconia, one of the constituent, major constituent composition. Okay. So another type of ceramics are carbides, and these are all modern ceramics we call. Tungsten carbide, titanium carbide, silicon carbide are the best examples where carbides are used to make cutting tools. If you want to make a driller, you make with a metal, and also you coat on the surface of the metal tool with a carbide composition. So you are making it very hard cutting tools. So mostly carbides are used in making cutting tools. Tungsten carbide with cobalt as a binder is used for cutting tools and dies. Silicon carbide is used as a abrasive and for heat engine components. Heat engine components, these are you have an engine in the car is also a heat engine, or aeroplane engines are also heat engines. So some of the parts in the heat engine are made by silicon carbide. So there is another classification is called nitrides. So boron nitride, I think so if you know the basic chemistry in 10+2, boron nitride is the hardest material next to the diamond. It is used for cutting tools and as abrasive in grinding wheels. Titanium nitride is used as a coolant material. Silicon nitride is used as a high temperature application. Okay, automotive engines and gas turbine engines. Okay, so if you see, there is a fundamental difference between alumina, zirconia, carbide, and nitrides. The ancient days, when people don't know that this is a ceramic, the ceramic compositions are mostly composed of oxygen. Aluminum oxygen, silicon oxygen, zirconia oxygen, okay, or something like this. But whereas in the modern ceramics, if you see, there is no oxygen. Carbides, nitrides, which are free from oxygen. So if you use a tungsten carbide or a nitride, you need to mostly use under reduction environment, not in oxidizing environment. But they are stronger than oxide ceramics. That is the reason why people engineered the modern ceramics and tuned the compositions such a way that they can use these ceramics to their specific applications. Something like the engineer or new ceramics, we call it as a carbides or a nitrides. And there is one more ceramic material which you use every day, that is glasses. We call it as glasses is amorphous, high dense liquids, and this glass is mostly made up of silica. Okay, silica is a very good glass former. That's why we use most of the glass compositions as a silica. Of course, within the glass, based on the elemental composition you use, of course, the majority of the composition will be silica. But if you dope with some alkali metals, or if you dope with the lead, or if you put some boron, then the type of glass we are using or you are making is different. Okay, something like in your window glasses, most of the things are soda lime glasses. For some specific applications, people make lead alkali glasses, but of course they are very carcinogenic. Lead is a very bad element. And you use borosilicate glasses. For example, you are using a screen protector for your mobile phones. It's a quartz. It's called high pure silica quartz. That's why it is very transparent. So if you understand from the slide 1 to the now, I gave so many products which you are using day to day, and they are all ceramics. There is a chemistry behind. There is a lot of chemical elements behind. And if you understand the nature of those elements, you can really come up with a a very good challenging and high-end ceramics. Still, if you remember 24,000 BC to current date, still people are looking for very good ceramics, and still people are working on ceramic research. It is just because there is endless options that ceramics can replace in our day-to-day technology. People still looking for lightweight ceramics. People still looking for thermally stable and very high temperature resistant ceramics, okay, which I will be discussing. So if you see, as I said, there are oxide ceramics, silicate ceramics, and non-oxide ceramics. I would say non-oxide ceramics are all advanced ceramics, whereas oxide ceramics are all traditional ceramics, or they have a long history in making them. Okay, so as I said, there are many applications, but today I'm going to talk about only ceramics that are part of the aerospace industry. Oh, okay, I forgot about this slide. Basically, as I said, there are many applications, right? So you cannot use alumina for all the applications, or you cannot use the silicon carbide for every application. So depend on the application. If you want a transparent ceramic, you use either soda lime or a silica or a transparent alumina. If you are using as a nuclear fuel, this fusion is also carried out by a ceramic material that's called uranium oxide. It's also a ceramic. Okay, so if you want to use some other applications like cutting tools, you always use tungsten carbide or silicon carbide. Okay, so based on the application, you can change the ceramic composition. That itself calls that there is a lot to work on these ceramics, because we have many applications that need to be increase the efficiency by changing the compositions, by replacing the materials, by substituting the materials with the ceramics. Okay, now let's go to the ceramics for aerospace and defense applications. So with these slides, I would say there are certain characteristics for ceramics. First thing, they are very hard. They have very high melting temperatures. They have temperature stability. Okay, they are very low thermal conductivity or electronic conductivity. So these are all the characteristics of ceramics now. So if you are finding an application for it, the application should be suitable for these materials also, or materials should be compatible with that application. For example, if you see the aircraft parts, any aircraft, domestic or commercial or war airplanes. So what happens? People wants to go as fast as possible. People wants to supersonic vehicles. You might have heard about that. So to increase the velocity, what people are working on it is making the aircraft as light as possible, weightless aircrafts. So when you are making weightless aircrafts, you change the body of the material. Instead of using metals, you can go to the composites. The composites probably, you can go to the alloys, something like aluminum, chromium, nickel. We call it as a super alloy. You know, aircrafts are also made with a couple of parts made with a super alloy, and some carbon nanotubes composite fibers. But you can change the body, but you cannot change the engine, right? Engine is the engine. It produces heat. If you change the body, whatever producing the heat should be stable, or the body should be stable with that heat, right? So the body should be having high melting temperature. And when people are working for that, so they are increasing the weight. So they don't want to increase the weight. They want to keep the weight low, but increase the temperature of the internal combustion engine. We call it as jet engines. How do you do that? Then people come up with certain material or certain coatings called thermal barrier coatings. What happens is you have a turbine engine or a turbine blade which is exposed to the high temperature. So this turbine blade is made up of a very lightweight super alloy called aluminum, nickel, and cobalt composition. And this temperature, whenever it is exposing, in between the turbine blade and the heat, you have another coating called thermal barrier coating. So as I said, ceramics have very low thermal conductivity, right? If you put some zirconia alumina composition in between the turbine blade and the gas temperature, this what happens, this acts as a thermal insulator. The temperature doesn't transmit to the turbine blade because it has low thermal conductivity. It doesn't transmit. That's same like your wall, your house wall, it's insulator. So with that, you can protect the turbine blade. Okay, so these thermal barrier coatings first came into that picture when they were coating onto the turbine blades. Of course, there are other applications for ceramic coatings. Another coating called abradable coating. Suppose if you see the re-entry heat shields on the picture here, and re-entry satellite vehicles, when they are entering into the Earth atmosphere from the space, they experience huge resistance, and when they are entering into the Earth atmosphere, their surface will get more heat, something like close to 3000 degrees centigrade. So if you are making that vehicle entirely with ceramic, then it will be maybe high weight. So they go with the lightweight alloys. But how do they protect that alloy? By coating with the ceramic materials. We call it as abradable coatings. When you coat these re-entry satellite vehicles into the Earth atmosphere, when you coat with the abradable ceramic things, what happens is they protect the metal part not to expose to the very high temperature, because they doesn't transmit the heat from other side to the metal body. But there is another problem. When they are entering into the Earth atmosphere, there is a lot of dust in the Earth's atmosphere. That dust will interact with ceramic, and it may develop and it may react because it is very high temperature, right? It may react and develop some cracks. So people designed specifically abradable coatings composing of clays. Clay means it's a kind of sand clay. So you have a layered structures and other things. So this dust easily dissolve into these layered structures and doesn't develop any cracks. So that is how you protect the surface of a re-entry vehicle. So if you see, first of all, ceramics are used where high temperature is involved. Okay, where you need to protect something from high temperature. Okay, where you want to have a thermal stability, chemical stability. It doesn't suppose not to dissolve in acids or bases, or it should show very high strength, even with the chemicals when they are entering into the surface. So wherever you need high temperature, wherever you need chemical stability, okay, wherever you need to protect metal parts from the high temperature, you use ceramics. If you imagine or not, more than 1000 metallic parts of the aircraft is coated with these materials, ceramic materials. It's completely from alumina, zirconia, silicon, that's it. And the fine-tuning composition based on the application. It's all from chemical elements. People still looking for lightweight ceramics when there is no need of coating, but use ceramics as a turbine blade, if it is possible. But there is one drawback. You cannot use ceramics as a turbine blade because ceramics has a very disadvantage of one thing, that is brittle. Okay, they break easily. That's why they are coating it instead of making as such as a ceramic. Two things, it's brittle and it is very high weight. You don't want to have increase the weight of a turbine blade. Okay. So these are the best example of a turbine blade. If you see, it is made up of with a super alloy. On the top, you coat as a bond coat. Some of the compositions bond coat. On the top, you coat a zirconia, the black one here, the zirconia thermal barrier coating. So this top coat, whatever thermal barrier coating, is only exposed to the temperature, not the blade composition. Okay, when it exposed to the temperature, for example, if you are experiencing here 1400 degrees centigrade, the ceramic coating, the turbine blade only experiences maybe 900 degrees to 1000 degrees. That is how you are protecting the turbine blade. If you don't protect the turbine blade, it immediately deforms the shape and it cannot perform as you expected. If you want to have a highly rotating turbine with high power, you need to increase the temperature. If you increase the temperature, then the turbine blade will go bad. So there should be an optimum between turbine blade and the temperature. By putting the ceramic coating, the temperature could be increased a lot. That is how people are working. This is another example of abradable coating. Abradable coating is mostly on the surface of the aircrafts, re-entry vehicles or launch vehicles are extra. So these abradable coatings are on the surface, whereas the thermal barrier coatings are only into the internal engine parts. Okay, so if you know how do we select the materials? Still, a lot of research is going on to make highly thermally insulating ceramic materials, even more than what you see currently. So there are materials which should have a low thermal conductivity, high thermal expansion coefficient, good erosion resistance. What is this thermal expansion? For example, you have an alloy and you have a ceramic material coating on the alloy. If the thermal expansion is when you increase the temperature, material expands. If the metal is expanding but not ceramic material is not expanding, then what happens? This cracks will develop. So when they are expanding, they expand together. So the thermal barrier coating ceramic composition should have a similar thermal expansion of the metal. Otherwise, it will develop cracks. So based on this, we can select the materials from this erosion resistance diagram. We can choose the material and work around the composition and find it. This is exactly whatever research going on in my group at SRM. We develop ceramic coatings for high aerospace applications. Okay, so how do we choose the materials? It's a very interesting question, right? You can say, okay, you said alumina, you said zirconia, you said carbides, tungstens, and everything. Then what else is left? What is the research left in this here? No, if you see, there are a lot of elements in the periodic table which has a similar properties like high temperature. How do you know that? So by knowing the melting points of these materials, oxides, a different class of materials like oxides, nitrides, borides, and carbides, based on the temperature stability, we select the composition and we fine tune the composition and we make the coatings and we use that as a thermal barrier coating material on a real time. Okay, this is how we work. So in our lab, my group is mostly working on zirconia based ceramics and magnesium silicate based ceramics and rare earth zirconium based ceramics. So this is another technique which maybe how do we know what is the melting point of a material, how temperature stability? So we make a small beads of the sample and we heat with a laser continuously and monitor the material structure by X-ray diffraction. At one point, there is no diffraction, which means the material is melted, and we note down the temperature of that melting point using a temperature sensor and find out what is the melting point of the composition. The melting point usually tells us how stable it is as a function of temperature. Okay, so you don't need that. So this is what we learned today. Basically, ceramics are compounds of metallic and non-metallic elements, possess high hardness, right? High compressive strength, high elastic modules, low thermal expansion, low density, okay, low thermal conductivity. Why? Because they are forming an elements between metallic and non-metallic. When we have a metal and a non-metal, what type of bond shall we expect in the ceramics? It could be either covalent or ionic. Mostly it's a mixture of both covalent and ionic. So the strength of ceramics are higher than metals because their covalent and ionic bonding types are stronger than metallic bonding. I think so. This is a very good 10+2 or a 10+1 topic. Which bond is more stronger or which bond is present in what materials? The metallic materials have metallic bond, whereas ionic materials are between a metal and a non-metal, whereas a covalent bond between two non-metals. Okay, so the ceramics, as you know right now, what are all the elements we have seen? Alumina, zirconia, titanium, carbon. These are all forming a bonds called ionic and covalent. Because of this high bond strength than metallic elements, these are very strength ceramic metals. They have high strength compared to metals. It is possible to obtain ceramic materials of any required properties. Yes, it is possible by tuning their composition. When you tune their composition, you can tune the mechanical, electrical, chemical, or magnetic properties. they have special advantages of lightweight, can withstand very high temperatures and aggressive environments. We call it as harsh environments. If I am staying in my room right now, it is very ambient environment. But if you go to the outside in the midsummer afternoon, I would say that is a harsh environment. Do I am survivable at a harsh environment? Yes, for a certain time, not for prolonged heating in a hot summer, right? So these ceramics are very stable in harsh environments, like a planetary environments. So the next science that everybody will be excited is space research, exploring the planets. I think so most of you might have watched Star Wars movies or Star Trek movies, where people explore the planets. We all see that's a movie, but there is a lot of science involved in it. Okay, so if you want to really mimic the Star Trek in the future, where people are going to Mars and people are going to the different planets, you need materials that could survive such a harsh environment. So there is a lot of scope for developing ceramic materials for future missions. Okay, so the bonding in ceramics is more rigid and does not permit slip under stress. Performance is much less predictable due to random imperfections and processing variations. That is the drawback of the ceramics. Ceramics may have a lot of vacancies, a lot of imperfections that could lead you unexpected results. But this is all what we need to develop is ceramics which doesn't have any faults. Okay, I hope I might have given some brief background about ceramics, how they came into the human life, and from the clay pot or a small Venus statue made by ancient people in 25,000 BC to now we are coating those ceramic materials on the aircraft parts. You see the science development from the very artifacts to the current technology. So this is entirely happened based on research and development that is carried out in ceramics, and that to materials, that to their bonding, that to through chemistry. Okay, so with that I will stop this lecture and I'll open for any questions from participants.
So, Dr. Parthasarathi, thank you so much for your wonderful presentation about the chemistry of ceramics and its application to aerospace industry. I hope your speech would have rekindled interest among our students and as well as the other participants who are here. I hope they will do the research in this area when they go for their higher education. I have received some questions, but based on the time constraint, I limit myself to 1 or 2 questions. The first question from Dinesh Kumar: why don't the ceramic particles gain kinetic energy and get deformed in firing it?
So basically, this is called a kinetic energy. We call it as erosion. Of course, when you coat ceramic materials on any metal parts, there will be loss of material on the surface. That it is, but it is not as instant. The material will be lost because of the incoming velocity of the air and anything. But of course, you need to maintain those metal parts by repeated coating after certain uses. Yes, they get kinetic velocity and they may lose some of the compound which we coat. Of course, we coat something like a 0.1 millimeter or a 10 micrometers on a turbine plate, let's say, so that eventually the coating will degrade over the time. Of course, it is after several uses.
Okay, thank you, Parthasarathi. And there is one more question, a simple one. So you talked about the several advantages of ceramics.
Yes.
So a participant, Vedavidya, so she is wondering about the disadvantage. Do you see any disadvantage in the ceramics?
Yes, of course. There is a lot of understanding about disadvantages too. As I said, ceramics or oxides or non-oxide ceramics, they may have a lot of defects, lot of vacancies, lot of problems in the processing of the ceramics in large scale. And also, ceramics has a very characteristic nature. They are brittle. That's why, as I said, we are not making a ceramic blade, but we are coating ceramic composition on a metal blade. If it is very good advantage, we would have made ceramic blade itself, right? because it can be a brittle and it may break easily. That's why we are not making. So the ceramics are very brittle. That's the disadvantage of it.
Okay. So because of a time constraint, so we have noted down the questions. We will also try to answer to you separately. And there are one more question was also left over by Nitin Kumar. He asked a question about draining. So our Dr. Sabyasachi Chakrabarti will provide answer. Before that, I take an opportunity to thank our Dr. Parthasarathi Maram for his wonderful presentation on behalf of the committee as well as the participants. Thank you so much, Parthasarathi.
Okay, so let me take that question of Nitin Kumar. I think Nitin, you asked a very interesting question. However, I hope that you know, if you see my screen, I think when you ask this question, you know what is source, what is drain, and what is channel, those things, which I don't have to explain it here because of the time constraint, but you can always write me an email, I can explain you even better. So now the first problem I heard grain, so that is why I didn't understood your question. But since you wrote nicely in the chat box that is drain, then I can understand and easy for me to give you answer. So you said that you want to reduce the doping concentration, right? But this is exactly to be the opposite side. To see, for example, for any devices, your idea should be the electron or the hole should flow from source to drain, right? So now if you increase the doping in drain over here, this channel width will be reduced so that your electron or hole can go smoothly, even more better way. If you reduce the doping concentration in drain, this width will increase, and as a result, the electron flow will be reduced. So the question you ask, it has to be the opposite. You have to increase the doping to the drain so that you will get more and more electron flow, so that your device will work perfectly. So with that, I stop here. I hope I answer your question. But again, you can go to our websites where our email addresses are there. If you really want to do more discussion and all, you will be always welcome to discuss. Thank you very much.
Thank you, Sabyasachi Chakrabarti. Sabyasachi, I also request, because I received some comments from the audience, that they would like to know about our university, where it is located, and what are the special features about our department. Can you please explain for 5 minutes?
Okay, so first of all, I'd like to, as you said, briefly, I would like to do. So I think my screen is visible to everyone, correct? So basically, we are in SRM University. We located in between Vijayawada and Guntur. And as you can see in the chemistry department, we have 5 faculties, and all of are present over here. And as you can see from the below, which I will again tell you, that we all have different diverse field of expertise in terms of research and teaching and everything. For example, our acting head, Dr. S. Mannathan, he is specialized in organic chemistry. And today you heard Dr. Nimai Mishra's talk. He is specialized in inorganic material chemistry. We have Dr. Mahesh Kumar Rabwa. He is specialized in theoretical physical chemistry. And also just now we finished a talk of Dr. Parthasarathi Maram. He is specialized in solid state chemistry. And myself, Dr. Sabyasachi, who is taking care this nanochemistry part of this department. Since you all, some of the question I see, what are the opportunities, or because I believe most of you are +2 students, so you will be thinking about what we can do in terms of chemistry. And by listening 2 of the talks, I think now if you have little bit of interest, I hope that your interest even grow bigger. So to boost that, I like to tell you what are the options available in our university for chemistry major subject. For example, we have basic chemistry, which is you can finish in 3 years. We have 120 credits. Then you can take chemistry honors, but you need to take 140 credits, meaning you need to do additional 20 credits in a department. A special focus will be given on materials chemistry. By now you know that our strength of our department. And also you can do this basic plus minor. I'm not going to go very details of many things over here because it will take again long time, but I would like to say, even if you want to go outside for, I mean, abroad for PhDs and all, or MS. So what we are offering here is we will offer you another 40 credits 4-year degree. There's a diploma degree that will really help you to boost your career to go abroad for doing PhD. Again, this is not the topic of today's seminar, but we are briefly mentioning. And if you have any question, you will feel free to write any of us. We will be very happy to answer you. Now, the curriculum, as I am showing over here, we design in such a way. We have foundation course that would be probably be new for you. I mean, if you know about the chemistry, basically you go chemistry, physics, and mathematics. But here, what we are offering here, we will offer you a course called Why to Read a Book. We will offer you a course of like communicative English to improve your communication skills. We will offer you a course of like data science and big data and data science, so that these days are computer science, computer based, right? So you will be well equipped with other subjects what is needed for you to be on the top qualified person while you are going for job or higher studies. But we will not ignore, we will have a lot of advanced chemistry courses. You will have opportunities like your second year, third year, you can go for summer intern, and we can send you abroad for your summer intern courses and all. And finally, all faculty are hoping that you could go for PhD studies in abroad. We will be helping you over there. And our courses are continuous assessment, meaning we don't rely on your like the final exam you do, whatever, that is the final. No, we will always monitor you how well, and if you have difficulties, we will be very happy. We will be there to help you to solve or to make you understand the subjects. So that will take care another 50% internal. So before the final exam, we'll in terms of various forms like midterm, like assignments, like quizzes, and so on and so forth. And this we already said that, I mean, briefly again I am telling, we will have supervised learning, meaning you, depending on your interest, during the last years of your study, you will be associated with any of the faculty. For example, if you talk about organic chemistry, you will be discussed very closely with Dr. Mannathan, our HOD, so that you will learn many basic knowledges and what is the research, what is happening over there, you will know. If you talk about computational chemistry, you can talk about Dr. Mahesh Rabba, you can understood what is happening in computational chemistry field. So something like this. And I think I'm not going to go details what is classroom activities. We'll do many classroom activities, and we will also focus on active learning. Another important part which I would like to share here is all 5 faculties, all are the active researchers. We have established several research laboratories, for example, nanomaterial laboratories, organic synthesis, or computational chemistry laboratories, where being a student, you will be more than welcome anytime to join, learn, and get hands-on experiences what is going on over there. So by this, I would like to stop, and I would like to end with that. You will have plenty of opportunities in our chemistry department at SRM University, Amravati. And if you have further questions, please write us an email so that we will be engaged with you even more better. With that, I stop.
Sir, feedback link.
Yes.
Yeah, we will provide you. We will provide you feedback link after some time. Please bear with us some more time.
Tomorrow or day after tomorrow about
Not only that, certification also we will provide you. Just bear with us sometime. We will send you an email.
Still, do you have any questions? You are free to ask.
Yes, we are here to answer the queries and all.
So if I see some of the road that they want to know more about nanochemistry. So what I suggest, you can please visit SRM AP website, where our chemistry department, you just have a look into our each faculty member CV, their research areas. We have explained everything on those detail. We also put our contact number, email ID over there. Don't feel hesitation to write to us. Please feel free to write to us. We are help you to take you to the another level. So, and we also welcome to join in case if you are interested to join in SRM AP. Then on behalf of all,
just last comment. I just share our chemistry department website. I think previously Dr. Parthamaram already shared. So I just shared our department website. In case you please bookmark it, so that it will be easy for you to navigate among ourselves to find out our faculty.
Dr. Mannathan.
No, I shared.
Mannathan.
yes.
Hello. This Dilraj Singh has asked, sir, career aspect of chemistry. In 1 minute, can you just say about that?
Yeah, you can talk about the career aspect. Partha?
Okay, Partha, are you?
Unmute. Unmute, Partha.
Yeah, sorry about that. Guys, a good question, because if I don't have a very good career options, I don't choose the chemistry program, or for that matter, any undergrad program. Okay, I appreciate that question, because everything is related to how well you can settle in your life. So first of all, if you are talking about undergrad chemistry program, I would not say you go for the job. I would not recommend, because higher studies is very important, that when you are in the science career. Of course, there are a lot of options that Dr. Sabyasachi Chakraborty discussed. If you do a 4-year program, you can go to abroad for pursuing a PhD, which is highly recommended, because it's a high qualification, always help you to settle in a higher position. Okay, if your situation or if your interest is not to pursue higher study, then what are all the career options? Of course, BSc chemistry. Chemistry is, as we said, it's a central science. It could connect to the biology. It could connect to the pharma industry. It could connect to the analytical labs. So there are a lot of undergrad analytical lab opportunities and pharma industry opportunities we listed here. It's a huge list, and many of our faculty are collaborating with the pharma industry. And I am collaborating, in fact, with Amaran batteries, which makes a battery, lead acid batteries and lithium ion batteries, and I work also on the energy storage and the harvesting. So you get an opportunity to contact with these industries, and you can also visit the industries and get contacts with them. And then maybe if you are interested, you can, we can help you to find a position there, or we can help you in a different places. Of course, we are there for you to guide to get a job after undergraduation program, but we don't highly recommend that. So in case if you are not, your interest, you had an interest and you went to undergrad program, and finally you decided maybe your chemistry interest is not so great and you want to quit chemistry, even that is also possible after pursuing undergrad chemistry program. There are a lot of government job opportunities where you can go for writing entrance exam and get in a central government or a state government jobs, where undergrad degree is something like a degree. You have undergraduation, so you are qualified for many entrance exams. You just have to pursue your interest in that. So based on your interest, I would say we are there for help you to guide you either for the job or for the higher studies.
Thank you, Partha. Do you have still any questions? You can write to us. Anyway, I thank all of you for participating in this exciting webinar. I hope
सर सर्टिफिकेट के लिए सर आपको मेल करना पड़ेगा या सर आप मेल कर देंगे?
हम लोग मेल कर देंगे. तुम्हारा जो डॉक्यूमेंट है हम लोगों के पास, we will give you the certificate. Don't worry about that.
Okay. Thank you, sir.
No problem.
Okay. Thank you so much for your participation. Thank you.
Thank you all.
Yeah. So I'm ending the meeting. Okay.